Okay, so here we are again. I'm back with Larry, and we are going to walk you guys through how to optimize a workflow. This is probably one of the most powerful parts of the new EFI RIP. The ability to optimize and create a three-dimensional color correction file on top of a workflow is pretty awesome. And this is probably going to be, again, one of the highlight videos that a lot of people will be looking at. So we're going to run the RIP.
Yeah, especially, Mark, when you combine it with the automation of the SpectroProofer. It's amazing.
Yeah, that's right. We'll assume we have a SpectroProofer, by the way, for this video. In fact, you just did this recently without a SpectroProofer. Wasn't it kind of a mess?
Yep, ran it on a DTP70, and I've been spoiled. So having to manually cut out targets and feed them and waste my personal time in front of a calibrator is not what I want to do anymore.
Yeah, I hear you. All right, so you know, the Epson SpectroProofer, as some of you know, is an option to the Stylus Pro 9900 and 7900 printers. We recommend, if you don't know the answer to this question, to get the version that has the UV filter in it. The version with the UV filter is the version of the SpectroProofer that was used to get the certification from the Ideal Alliance for both Grackle Coated 1 as well as Swap 3 and Swap 5. But we have found, Larry and I have played with the unit with the UV filter and the optional SpectroProofer without it, and I really can't tell that big of a difference.
I've switched it in between jobs, created characterization sets with the UV cut and then verified without it, and very, very little difference. The software really takes control of everything that needs to be done.
So, you know, one of the big benefits of Epson proofing media, obviously, is that we don't have as many optical brighteners in some of the medias. And since we've tried to reduce it the best we can, I guess the use of the UV version of the SpectroProofer is not as critical. So anyways, we're going to assume that this Stylus Pro 9900 printer has a 44-inch wide Epson SpectroProofer with the UV filter installed on it. It's going to make the ability to create a complex three-dimensional color correction file all automated. And it's going to be, again, a very, very slick system the way this thing will work. So basically, what are we doing here? Well, we've already created a workflow for the Grackle coded specification. The information in this workflow is set through a number of settings that we've done in a prior video. And then, of course, we have an output device, in this case, an Epson Stylus Pro 9900 that is set up on the network and has a certain media type to it. What we want to do now, and by the way, if you do not create a three-dimensional color correction file or you do not optimize this workflow, you will still produce very sellable contract quality proofs. In fact, the proofs will be better than probably anything that's out there today. But after we are done creating a optimization or creating a third file, which we call a three-dimensional color correction file, the math that the EFI RIP will use now with all three files, all three information points, the input profile, the reference profile, the output profile, and of course the three-dimensional color correction file, the accuracy will come up dramatically. I mean, it will be like below delta of like 1.
Yep. Right out of the box, if you set your verification to delta E2000, turn on the control strip for the Ideal Alliance and run a proof, even without doing this 3cc correction process we're going to take you through, chances are you're going to pass.
Yeah. All right, so we're going to show how you can make this insanely accurate for this workflow. The first thing you want to do is make sure that the workflow that you're about to optimize, and that includes the workflow and the output device, is what we're optimizing the color for. We first want to start off by just double checking that all the settings in this workflow is correct, because once we've optimized these two together, you don't want to mess with any of the settings, both at the workflow side and the output side. It's tied together. So first we're going to go through this setting, make sure that these settings in this workflow meet the specifications that Epson set here in our office in Long Beach to make sure that we pass the certification from the Ideal Alliance for Grackle Coated 1. Here are all the settings for general. And again, we went through this in a prior video, but I'm just kind of going through here, making sure nothing has changed from the prior video that we've done. Making sure my job layout, my nesting step and repeat are the way they were before we optimize these two. Key is to double check color management, because obviously you're going to be optimizing the color management of this workflow to the output of this printer. So we want to make sure we are doing an absolute color metric rendering intent. And we'll show you a trick on how you can use this absolute colorimetric rendering intent with or without the paper tint being put down, so you can ignore this selection here where it says paper white. You notice down in here under lab optimization, right now it says none. When we're finished with our three-dimensional color correction file, we will be able to pull this menu down and actually select that file from this pull-down menu. When we do that, we will then save this, and this will become a very, very accurate workflow for matching this standard. So I'm just going to go through here and make sure everything is good. One note is, in the video, we asked you to select a simulation profile here. Since I've already had the certification completed by the Ideal Alliance with it turned to none, I'm going to turn that back to none just to make sure I'm safe. Again, anytime you make a change to anything, whether it's here or here, this little icon will light up. Just make sure you hit save. It goes gray. Now you have all your settings done. Just make sure everything looks good. By the way, you obviously don't have to worry about verification. I'm going to leave verification turned on. Obviously, we will not, and the RIP is smart enough to know that as we create the three-dimensional color correction file process, we're actually not going to be automatically verifying every target. It knows it's smart enough to ignore this information. It'll use it for printed data. So it looks good there. I'm just going to make sure my printer is set up properly, have the right paper installed that I want to optimize these two items for, my workflow and my output device. Everything looks good.
So we're going to standard proofing paper 240 at 1440 DPI.
You got it. Right. 1440 input and 1440 output, which is really the main resolution I think that most proofing shops will run at. It's a good combination of quality and speed, and everything looks pretty good. All right, so now that these are all set, we're going to create an optimization file, and we're going to do this automated through our optional Epson spectrophotometer, which we call SpectroProofer. Again, this process was done earlier by Larry through a DTP70. It's just a nightmare to kind of go through printing all these patches, cutting them out, reading them in, doing it over and over again. The iterative process of trying to fine-tune the color management by that math is complex, very time-consuming, and it's something that a lot of people will pay a consultant to come in and do. But we can do it completely automated here with this new Proofing Edition bundle and with the work we did with EFI. So the first thing we're going to do is select the workflow. You don't really have to, but I always do just to remind myself that's the one I'm going to be optimizing. Up here on the dock, you'll see that we have a Color Manager utility. We're going to click on that. It launches the EFI Color Manager. We are going to select Optimize Profile. We're going to make sure the measuring device that is going to be used to read in all these patches as we go through the process of creating a three-dimensional color correction file is the Epson SpectroProofer. Again, just the cost of this process alone in manual labor costs of one of your employees will pay off buying the SpectroProofer hardware.
Very quickly. I
mean, it's only a $1,500 purchase at list for the 24-inch model. What is it, $2,500 list on the 44? Yeah. Yep. So if you do this just once, with a guy that you have in your shop, you've probably paid off, you could have paid off the purchase of this device with one iteration. All right, so we're going to optimize and create the three-dimensional color correction file using a random IT8 target. That's the best target to use. Since I know this printer is a 44-inch wide printer, but I have 24-inch wide media in it, I'm going to optimize the use of media by selecting the width here. This creates the targets to take full advantage of 24-inch wide media that's installed in the printer. If I had 44-inch wide paper installed, I'd select that, but I'm going to select 24-inch. You could select, obviously, 24-inch or smaller if you have 24-inch installed, but this does not speed up, by the way, the reading and everything. It just saves paper, right, Larry?
That and 24-inch is what you got in the box with the Proofing Edition.
Good, good. All right, so now we have to select a workflow out of the RIP to optimize. You notice you pull down this menu. It sees the workflow we just created, so I'm going to select that. This utility goes out and talks to the server and grabs all the data that we've defined in that workflow, both input and output. And it says basically that we are going to optimize the output profile. In this case is a standard proofing paper 240 at 1440 DPI and all the settings I set in the printer. And we're going to optimize the color matching between this output device and this reference profile, which in this case is the Graycall 2006 coded 1v2 spec, which is part of this workflow that we set up. The next thing we're going to do is talk about paper white for a second. You could ignore the optional additional characterization data. You'll rarely ever use that. Under paper white settings, you have the choice to use either the default, which means that if you select default absolute color metric, that means that if you make a print and the paper color is different than the paper color that's defined in this reference profile, we will automatically put down a tint to tint the background. That works extremely well. Yep. But If you have Epson standard proofing paper used and you're trying to hit grackle, you actually have the choice where you don't have to do that. In fact, if you do it, by the way, you're safe, but you may notice you can barely tell the paper tint is being put down. The paper is so close already to the standard that was set by the Ideal Alliance for a grade call 2006 that you could, if you wanted to, select suppress paper white, and you will still have a certified workflow. In fact, that was what we sent in to the Ideal Alliance to be certified, where we did not put the paper white down. Now, this is important to know. Three-dimensional color correction technology only works with the absolute rendering technology. It will not work if you select the relative colorimetric rendering intent within the workflow. So as you may have remembered, in this workflow, we told the CMYK side of the color management system to use absolute colorimetric with the paper white. Absolute colorimetric is the key thought there. That math is the only math that's compatible with the three-dimensional color correction technology from EFI. So if you create an optimization and then you go back to your workflow and select relative, none of this is working. None of this is kicked in, even though you have it selected. Is that right?
Correct.
All right. So what we want to do is make sure that if you have a decision on whether or not you want paper white being put down or not, you don't do that by selecting relative colorimetric, which is what we used to think of.
You could do relative colorimetric, no paper white, but it's not going to be nearly as accurate as the process we're going through.
And you won't be able to take advantage of the three-dimensional color correction data either.
Right.
But it still looks okay.
And you risk not passing a verification.
Yeah, it's a good point.
Not that accurate.
So I find that the best way to handle getting extreme color accuracy to a workflow, and by the way, we're going to, when this process is done, as we said earlier, the accuracy that the 9900 class printers will hit, especially because of Ultrachrome HDR ink, it's going to be so tight, you're going to be far tighter to the accuracy than any press will ever match it. But if you do not want a paper white being put down for the contract proof, then say suppress paper white. The optimization method, we're going to create a new lab correction file. Then we're going to automate this process by saying just do the optimization automatically, do it 5 times in a row, and then be done with it. I can also tell it to continue to do it until I hit a certain delta E, but I have found it's best just to check that, select 5. I would select no more than 5. What do you think, Larry?
I think the sweet spot's between 4 and 5. You start getting diminishing returns after that for the time.
So I would say 5, hit next. And then this is where you will see all the activity happen. We're going to go ahead and say print the chart. Yep. What's happening right now is the EFI RIP is creating the target. It's sending that target to the RIP. It's taking care of turning off color management where it needs to and all that. And it's sending the job directly to the printer. The printer is now printing the target. When the target is done printed, because we do have the Epson spectrophotometer, which we call SpectraProofer, installed on the printer, when the target's finished printing, it will automatically roll the print back into the printer, and the target will automatically be read by SpectraProofer. SpectraProofer then will send that data into this EFI RIP automatically. It will analyze the data, and it will create information displayed here for every one of the iterations. And in the end, when we have found that we can no longer improve the color match any further, we will select the best choice and hit finish. So to help speed up this video, I'm going to go directly to all the different settings.
I'd like to back up 1 second. Before you hit print, personal recommendation, go to the control panel on the printer and set it to the auto nozzle check to on every job. Basically, since this is an automated process, you want to know that there's no issues. The printer's going to look at it, make sure the nozzle check is good, and then print, and you're going to have a perfect optimization. So
yeah, it's a good
once
tip.
that's done, you can turn it to either off or on periodically. But when you're doing an optimization, turn it on for every job.
You know, to be honest with you, why not leave it on for everything? You know, in the unit that we have in our lab, I don't think I've ever turned that feature off. Just basically from the control panel of the printer, just tell the auto nozzle check to be on every job. I mean, is there any?
It takes a little time. Personal preference.
Like 30 seconds.
Yeah, that's our printer's so fast. 30 seconds.
To guarantee
is a big
you never
deal.
have to deal with you never deal with the nozzle clog. So yeah, that's a good trick. So we're going to kick back up here. When these are all done, basically, you know, we would send this down and go to lunch and then come back, and then we'll kind of see these finished.
It's about 20 minutes per iteration. So we set it up for 5. We're about an hour and a half. So a nice long lunch.
And the great thing is that it's automated. I don't have to be involved.
Right.
I come back when it's done, so I don't have to deal with it. All right, so we'll see you when this is all finished. Okay, so we just came back from a long lunch, about an hour and a half. Larry was about right.
Yep, no martinis for me.
No martinis for you? I had one of them, I think. All right, so you can see here how the RIP finished all the iterative color. It did all of the optimizations that we told it to do 5, so you have 5 listed here. Just to kind of point out, you can see where the very first accuracy, how it read the very first accuracy level against the workflow. This is the difference between how the output device is performing versus what we're telling the output device to match to. In this case, it was, again, that workflow we created for Kako.
Yep, I should say that the math used for the delta E calculation internally within EFI is delta E76, where in the verification we're using delta E2000. So delta E76 is actually one of the earlier standards and doesn't take into account perceptual considerations. So numerically, it's actually one of the most severe delta E standards. So our actual verified print is going to look probably better than the numbers you're seeing here.
So, when we use delta E2000 as a way to verify proofs, you're going to see much smaller delta E numbers than what you see with this.
Probably.
Okay.
Yep.
All right, so you can see how we started off with pretty good accuracy. You're seeing the overall delta E without any optimizations at 2.17. Again, based upon the delta E method Larry talked about, if you were to use delta E2000 to calculate these delta E's, that would probably end up being about a 2 or a 1.95 or something like that. But you can see just out of the box how accurate it got. But as we start to optimize and create the first three-dimensional color correction file to be used in addition to the output profile and the reference profile, you can see how much we've been able to cut the accuracy. This one jumped up a little bit. That was because we told it to use suppressed paper white, so the very first one out of the box will be high. You'll see it dramatically drop, though, on the second iterative number. So you can see how much lower these are getting. And as we continue to create optimization files, as we continue to print out targets with the data we've had prior, use that information in the math to try to get tighter and tighter tolerances. You can see by the time the 5th one came, we were able to go from an average delta of 2.17 to an average below 1. That's just awesome.
Right. So we talked about going 4 or 5 iterations. If you look at the numbers there, actually 3, 4, and 5 are pretty close. So it's just a matter of choice. There's nothing wrong with going more, but either one of those is perfectly fine to select.
And you can also get a little reading here. It says the average was improved on number 5 is what I have selected. And you can see that, further improvements they're saying could be possible, but as you get below delta E of 1, you start to get to this level, it's just so accurate.
Right.
Any more at this point is probably not worth your time.
Yep, I agree.
So now that we're happy, and by the way, if we were happy with 3 over 5, and sometimes I have found that the 5th one could go reverse and go worse, but in this case, it actually got better. The 5th was the best choice. But if you basically, EFI will automatically light up the choice that's the best. In this case, you can see it's green, so that's what I'm going to select. That means it's the best choice out of this iterative process. We're going to go ahead and hit Finish. Do you sure you want to save step 5 as a new profile? And I don't know if it says profile. It's, I guess in a way it is. It's a three-dimensional color correction file, .3cc, not ICC.
Right, but it's important to understand it's not overwriting your media profile or anything else. It's actually creating a new file in your system with a .3cc extension.
Yeah, and that's good to know because it's not modifying my current output profile. It's not modifying the Kako profile. This is a third file that's being used within the EFI math for color management to make all this work. We're going to go ahead and hit Yes. And now we're going to go ahead and save this file out. Larry, do you have any opinion on what the file structure naming should be so people get this right?
I do, and I'm pretty specific. So we're doing this for a Kako workflow. I actually dropped the 2006 because it's going to get a little bit long. It's then tied to a media type, so we're doing standard proofing paper 240, so I do SPP 240. We're also tied to a resolution, so in this case it was 1440. And my last item is the type of optimization. So I use an acronym, DAC for default absolute color metric, or in the case of what we did here, I would use SPW for suppressed paper white. And the only other thing that you might want to add is a date, but other than that...
Or like version 1.
Or version 1 or something like that. So it's a personal preference, but it's important that you give it a name that you understand how it's linked to the reference profile, the media, and the resolution, because that's where you get your optimal results.
And you notice as Larry was saying that I was putting underscores in instead of spaces. I don't know why. I think it's just only because I want to be safe with the EFI file structure.
All right. Well, if you look at how the RIP names things and all those 17-inch optimizations and 24-inch optimizations, it's just following that same convention.
So we'll go ahead and hit save, and it's asking me would I like to use this new three-dimensional color correction file as the default lab optimization for this workflow, and obviously that's yes.
Yep.
Saves us a step from having to go back to the workflow and select it. We're now finished. I'm going to go ahead and hit exit. What's really great about this is that all of this was done automatically. I mean, I didn't have to be manual labor costs of cutting prints out and doing this over and over again and trying to feed these through devices like a DTP70 or an ISIS. So just to make sure everything's working, let's go ahead and make sure we select our workflow, go to color, scroll down and make sure under lab optimization that new 3cc file is there. It automatically went there because we told it to save it there, but if it wasn't, you can pull this menu down and select it. Make sure that this is saved within your workflow and you are done. At this point, any print that is now made with this workflow, and a great test for this is to do this, make a proof before you select that 3cc file and let the verification feature auto-verify and print out the label, because the verification label will give you delta E numbers, and then select that 3cc file in the workflow and print that same proof out and watch the difference. It's quite amazing what you can do. And I guess the real big thing about this is that we are now able to produce extremely accurate contract quality proofing to virtually any workflow that you can define within this software, and then optimize the color management to make sure it's dead on accurate without having to be an expert in color. Is that kind of a good way to sum it up?
Perfect.
All right. With that, we are done with this video.